Simple example of a projection. Let's project the vector u that you see here on the vector v. Now, I played around a little bit with these vectors, which explains some of the smudges on the board. Kelly got a picture that I thought was illustrative. Okay, so anyhow, here's the vector u, 4i minus 6j, 4 in this direction, 6 in this direction. So that a unit is probably about this big here and about this big on the x-axis. V is 2i minus j, so we come out 2 units here and down 1 unit, and here's our vector v. Maybe not that easy to see. Still probably not that easy to see. We'd sketch the line through V, that would be the line L that we talked about previously, and I could kind of label that line L. But our vector u projects onto the line L defined by the vector v. The projection is easily calculated using what we have here. Remember that u dot v over magnitude of u is just equal to magnitude of v times cosine of theta. So okay, well, we're going to use this because I have opposite notation here. We want to project u onto v, projection onto v of u. So we have the u dot v over magnitude of v, which is just the length of this side. And since the angle between these two vectors is clearly less than 90 degrees, we understand that this is going to be positive. Well, we can calculate that. U dot v over magnitude of v is just 14 over the square root of 5. I'm not going to go through the details of the calculation, they're very straightforward. And that's around 6. So that this vector has a magnitude of about 6. Now if this distance is 1, it's very plausible that that's 6. In any case, it's the length of the adjacent side of this triangle whose hypotenuse, the right triangle, whose hypotenuse is u. So, when we look at this triangle, here's our projection, and here's the vector u. Here's our angle theta. The length of this side is just 14 over square root of 5. 2i minus j over square root of 5, well, that's just our v vector divided by its magnitude. So that's a unit vector in this direction. So that might be this vector, the 2i minus j divided by square root of 5, which is just v vector divided by its magnitude. We multiply this distance by this vector and we get this vector. So we want to sort out that idea. Now I went ahead and did a calculation, and that calculation is straightforward and not particularly interesting. Once we're here, we can easily do the rest of the calculation and compare it with our picture to see that it's plausible. Another aspect of projections, well, we'll go on and talk about this separately.